Hey everybody, welcome back to Young Engineers of Today. I hope you guys had a good weekend. I hope it was, you know, full of adventure, but like the good kind of adventure. Bad kind of adventure is not, that cool. But hopefully it was the good stuff. Hopefully it was good. Anybody do anything interesting? Sorry about that. I was removing my hat. That probably made a lot of noise. Well, okay. Seems like everybody had a pretty laid back weekend then. Um, we are going to revisit the subject that just won't die. We're going to work a little bit more with Fusion 360 this week. Not much, and it should probably be only this week based on everything I've seen. But this time it's going to be a little bit more tailored to Othermill. So we're going to spend some time talking about maybe the different things you would do with Othermill, since that is, as I understand it, the brand that you will, those of you in Raleigh, you soon should be um, getting some hands-on time with the CNC machines. And I believe those of you in Charlotte have probably already messed around with the other mill somewhat. But anyway, um, this is just kind of a fun little project to get you guys sort of more familiar with the other mill parameters and how to run the other mill drivers and everything like that, so that it's not a guessing game for you, at least as much. Um, there's still obviously some figuring out of different things that needs to be done and everything like that. But as far as this is concerned, uh, it'll get us a little bit more familiar with with other brands of CNC machines, so that you guys can learn to work with that as well. And it'll be a little bit more in depth on the machine driver side, the actual final steps before milling. Than the bookcase presentation was. A lot of that was way more focused on uh, creating the actual design and learning all the different features of Fusion 360 and blah, blah, blah. This we're actually going to start with an already completed design because we already know how to make a thing. We're not going to mess around with making a thing again. And this time it's going to be, a less complex thing, which, would be a lot faster, but as it stands, we're just gonna go with the already completed design because why not? So in this case, they're going to be rings. Um, kind of you put on your finger. If you were so inclined, you could probably make the kind that Sonic the Hedgehog would grab, but those would be a lot more complex on a CNC machine. So we're going to skip on that for now. We're just going to do the rings that you're more familiar with, probably. Oh, it would be kind of cool to do like a gold ring, like a Sonic the Hedgehog ring. Looks kind of like a thin inner tube. Uh, I get sidetracked really easily. Anyway, let's dive into this. Oh, and just so you guys know, after this is done, after we are done with Fusion 360 and all that, we should get started on circuit design, which will be a whole nother beast from 3D modeling and CNC and stuff like that. So that should be pretty cool, hopefully. Circuit design, you can get into the nuts and bolts of software that simulates how a circuit will work. So you can build anything from like a really simple switch to vastly more complex things once you get more familiar with it and electrical design in general. Um, Again, if that's something that particularly piques your fancy. If not, like I said, we got plenty of other subjects we're going to go over, but that's going to be the next one on the docket is going to be circuit design, which is it's an interesting thing. I've taken some electrical engineering classes at State. Um, it's a very interesting process. There's a fair amount of math involved, but that's why we have computers. Computers will do that math for you, and then everybody's happy. But anyway, we'll probably spend some time going over that math too, so you guys know where it's coming from. You knows. Suddenly I'm Squizgar. You guys knows where's it's coming from. So, like I said, a ring. Nothing crazy. Just a nice little simple design. It'd be kind of neat though, very something that you could wear, like if you were so inclined, and it would be something that you made. And that would be kind of cool. Alternatively, when you get to that point where you find somebody that you care about, you could potentially make them a ring and have the emotional impact behind it being, something that you made. Anyway, like I said, this is going to focus more on the other mill side of things as well as everything after the modeling step. So we've already got a model that we're gonna get started with, and let me go ahead and put this link into the chat box. And if you click on that, it should automatically take you to the download. I'm going to cancel that download because I already have it on my computer. I really don't need another one. Close. We'll give everybody like a few seconds to get that downloaded. It doesn't take too long. It's a very small file. And in the meantime, I'm going to go ahead and I'm going to get Fusion ready. So that's sort of figuring its stuff out while you guys are getting Fusion started up. I'll just go ahead and talk a little bit about the project that we're going to look at. It's going to be a ring. There are customizable aspects of it, namely the diameter of the ring. So the ring size, which is kind of an important thing because everybody has different size fingers. I have little, long, thin, creepy fingers, and somebody else might have like perfectly normal human fingers. And there are varying degrees of perfectly normal human fingers as well. So that is one of the things that can be changed through an aspect which we're already familiar with. Can anybody take a stab at where the information about the ring might be stored, like the ring size and everything? Something we set up once and we used plenty throughout the creation of the bookshelf. So thinking about what it might be. Yeah. So ply is an example of this. But yeah, I like the direction that you're going in there. The sort of the variable that we created. There was a specific name for it though. Parameters. Yeah. User parameters. Same idea here. The user parameters store information about the dimensions of the ring, so that if we ever get into a situation where you want to change some parameters or you want to change some dimensions on it, all you have to do is change the parameters, and everything will automatically update on the ring or whatever design you have. In the case of the bookshelf, we could change ply, and the thickness of everything on the bookshelf would update and change and all that good stuff. So yeah, user parameters, and ply is an example of one of those. So yeah. Now, I'm sure everybody's Fusion is probably started up at this point. I already had mine open, so I don't have the advantage of knowing exactly how long it takes for my computer to start it up. I just have to guess at it. So let's go ahead, and hopefully you guys have it open, or if you can get it open or whatever, and we can take a look at this. Woo! Drawing lines. Let me close all this stuff. Yeah, don't save. And don't save. Ignore the fact that those were rings. Those never existed. So the way we import this is by clicking on the little file icon in the upper left-hand side next to the 9 squares. Not the 9 squares, but the file icon. It's the little piece of paper with the corner folded over. And you've got a few different options. You got new design from file, new drawing from design, from animation, related data. There's no related data. Save, export, live review session, 3D print, capture image, view, scripts and add-ins, Autodesk Exchange apps and add-ins, in parentheses, legacy. It's a lot of stuff. We're actually not going to mess around with most of it. What we're going to do is we're going to click on New Design from File, because we're going to take this ring and we are going to open it up. So let's go ahead, and it defaults to my Downloads folder, which is where I downloaded it to. And I'm going to click on it and hit Open. And look at that. There's a ring model already finished. Now, granted, it's not like a ring would have really been that difficult to make. It's not like, we had to create all kinds of interlocking parts like we did with the bookcase and model this whole thing for ourselves. It's just a cylinder with the middle missing. But regardless, our lives are made easier by not having to generate this design from scratch. And so, same idea. We can go up to, oh, good Lord. Oh, I'm in cam mode. Let's go back to model mode. There we go. We can go to modify and then change parameters. And there should have been user parameters here. Maybe those didn't import. Let's see here. Click around for a moment. Nope. That is totally an error on Fusion's part. Those should have imported. Oh, no, never mind. I'm bad at Fusion. Okay, under model parameters. Haha. I'm just really bad at Fusion. Under model parameters, there's this untitled one. Notice how that is the name of the model that I have open right now. Untitled and then one in parentheses. You can click the little triangle next to it to expand them. And then you can click the little triangles next to cylinder primitive 1 and hole 1 in order to expand those. And you can get the different dimensions that this ring has. So height, diameter, hole depth, hole diameter, tip angle, all this kind of business. These things are, well, the parameters of the ring, as one might expect. Cylinder primitive being the size of this outside ring right here, and hole being the inside, as one might expect. Boy, it's a good thing they used helpful names. Oops. Yeah, so hole depth, hole diameter. Basically, these also are, as you might imagine, height is how tall the ring is. So this would be height as well as hole depth. Those are the same, because obviously the ring has the same depth on the inside as it does on the outside. And then you had the diameter and the hole diameter, which again, as I explained before, hole diameter and regular diameter. And this is a little bit further. It's supposed to represent this outer ring, this outer wall. In most, well, in other situations, you would get a, you would find out your ring size or the ring size of whomever you were making this ring for, Usually a pair of calipers does the job pretty well, but you would get the dimensions of the diameter of the ring. In this example, obviously, it's 0.78 inches. That's the diameter of the ring that he has, that he's making. But for somebody else, it might be less, it might be more, it might be just like a little slightly off, so it's like really uncomfortable to wear, but it's not enough that you can't get it on or get it off. It might be a little bit too loose so that it flies off, whatever. So you wanna make sure that you've measured it as precisely as you can, which is why calipers are being used here, so that you can update the parameters here to something that is more accurate. So let's see here. Let's just say, since I have weird spindly alien fingers, let's say my whole diameter is 0.6 of an inch, 0.60 inches, and this one then, oh sure, yeah. Whoop, here we go. Sending it through the chat again. Send. I don't know why it put brackets around it, but if you just copy paste that without the brackets, the angled brackets in the front and the end, and put it into like Chrome or something like that, it will automatically download it. But yeah, so I modified the ring's parameters in my case, so it's smaller. I made the diameter just 1/10 of an inch more than the hole diameter, so that hole with no W, so that the ring is still very thin, like it's a thin band of metal. Because otherwise, if you just update the hole diameter to something less or more, it's going to keep the outer diameter the same, and you might get one of these strange situations like I had here just before I updated it, where you get this really thick ring, and that doesn't really work. So let's go ahead and put that in, hit OK, and it updates so that it is thinner. That's it. Once you update the model parameters like that, that's all you need to do. Model is done and ready for the cam side, which you guys should already be pretty familiar with too, at least to a certain extent. We'll spend some time going over the cam stuff too. Now, they actually made the cam mode much more expedient with this model as well, and you'll see why in a moment. So let's go ahead and over into there. And you'll notice in cam mode here, you'll notice that there's already a setup, and there are already a couple of toolpaths. Well, tool setups, rather. So there's setup 1, and then there's T1 face 1 and T1 ramp 1. So not only did this guy set up a model, he actually set up, a setup for the cam mode. Bit of an issue, though. Those tool paths were very specific, right? They were meant to, they were meant to tell the tool to travel a certain distance and drill and stuff like that. Those tool paths were set up while the ring was still its original size before I updated it to be a thinner ring. So we need to fix that somehow. However, Fusion 360 is actually pretty good at fixing that for us automatically. So what we can do is you notice next to these tool paths, there is the exclamation mark in the red circle, and then if you mouse over it, it says Invalid Toolpath. It's simple enough to fix. It just involves us right-clicking and going down to the option labeled Generate Toolpath. Just click that, and it will spend some time thinking, and you'll get an updated toolpath, which will be correct. So hey, look at that. We've got this updated toolpath, which is now starting from the top of the assumed stock. And if we click on setup, we can see the size of the stock. It's actually significantly larger than the ring itself. but it starts from the top of the stock and sort of generally whittles its way down to the top of the ring. Pretty useful. And this is the tool for it. We can do the same thing with T1 Ramp 1. Right-click on it, then select Generate Toolpath. And it will think and think and think. And once it's done, we'll have a ramp as well. Cool. It was really painless. In fact, if we were to look at any of this stuff, like look at right-click and select Edit, all this stuff's been selected for us. It's got a 1/8 inch flat end mill, or 1/8 of an inch, whatever your preferred nomenclature is. The spindle speed and the cutting feed rate and stuff like that are already fed in there and calibrated for other mill. But it's always good to take a look at the stuff. Like it's got a 1600 RPM or 16,000 RPM spindle speed and a 59 inches per minute cutting feed rate, which is a little bit different than what we were using on the ShopBot. Likewise, the lead-in, ramp, and plunge feed rates are all significantly lower. Remember, we set those to 60 when we were making the bookshelf. And the lead-out feed rate is less as well, although not quite as much. It's 40. But for us, this setup was a lot less involved on the bookshelf as far as the actual numbers are concerned. Like these were all just 60 right here. And this was, if you remember, these two were 10,500. So it spun much more slowly, but it moved much more quickly. Like the actual tool moved laterally much more quickly, but spun not nearly as fast. Anyway, again, it's already been all set up for us, so we don't have to worry about it. We've already got the spindle speed and the ramp spindle speed and all the feed rates set up. So we can just take a look at this, see what they've got, and then when you're satisfied with it, hit OK. Yeah, the geometry is fine. We don't have to worry about that. The heights. It's just kind of interesting to look at this kind of stuff. It's got a very low tolerance, or a very high tolerance, depending upon what. Anyway, it's meant to be very precise. It's got a lead in. We'll just click cancel. That's always a pretty safe thing to click when you're not sure if you've made any changes and you know you don't want to make any changes. You can just click cancel, and a program will just revert it back to how it was before you selected edit. We can do the same thing. Take a look at this. Same settings in the tool here. You'll notice that, remember how when we were working with the bookshelf, the maximum step down was actually much, much larger. This is 2/1000ths of an inch per pass. So basically it cuts, and it cuts 2/1000ths of an inch off of the top each time. You guys have any idea why the step down might be a lot smaller on this model? Has to do with well, that pretty much gives away the answer. It has to do with the material it's made out of. The bookshelf being made out of a nice soft plywood, you know, we did multiple depths so that it didn't really like chew up the material too bad. But on the whole, we weren't nearly as worried about the tool. It was just going to cut holes out of the material and, you know, sort of do its thing and be okay. However, on something like a ring, that's going to be made out of metal, especially because on this particular project, uh, they recommend using like an aluminum or something like that in order to avoid metal allergies. So it's going to be something that's significantly more difficult for a tool to cut through, especially a flat end mill. It's going to be a lot more work. Um, it's a lot harder than plywood, certainly. So we go with a smaller step down in order to, sort of help preserve the tool life. We don't have to worry as much about it heating up too much or anything like that, or getting stuck in the material because it's actually shaving off less with each pass. So that's why we're doing that, is just so that it's easier it's easier on the tool and it's easier on the material, and it helps to ensure that we're not going to get any sort of like catastrophic errors. Anyway, we'll hit cancel again just to make sure that we don't make any accidental changes to the tool paths. And if you really wanted to, this is a valid tool path. There we go. It was just unhappy about the fact that I clicked on face instead of setup. If we really wanted to, we could simulate it just to make sure that everything kind of goes as planned and nothing really messes up. So we'll speed it up a little bit, see it's just taking off a little bit of material each time. We'll get rid of the tool paths so that you can more easily see that. And you might not even be able to see that. Like it's so slight that there's just a little line. You might be able to see it on your computer, but certainly not on mine through the internet like this. The bitrate just probably isn't high enough. But anyway, it's doing its job. It's working. We can sort of bring it down along a side view so that you can see more easily the material getting shaved off bit by bit from the stock. Speed it up a little bit more. And it's going. You can really see like the material being pushed, like shaved off now. And then at some point, once it's done shaving off material, it is going to transition to a ramp. And look at that. Very top of the model is now starting to peek through, and that's not actually what it's going to look like in real life, but we're still visualizing the model in this mode, so we can see it peeking through. So now it's starting on the inside of the ring. Bit by bit, again using a very slight step down. This would be quite a process in real life. Wouldn't be horrible, but it would be a lot of it wouldn't be insignificant either. So there it goes, it's cutting it out. Notice it's leaving some space in the middle because again, that just doesn't really matter. Like that space is just going to be a little piece of metal. That's just going to be free floating. And that's the side effect of having this ring here. Just like it was a side effect of the slots in the bookshelf to have like a little bit of material in the middle. All it's doing is it's tracing a line, so it's going to leave that there and not worry about cutting it out. Visualizing the toolpath is a bad idea. There we go, unless we do that. You can see we're almost done. Who's excited? And with that, we got a material cutout. Cool. So once we're certain that this is all like okay, nothing's gone wrong. We've looked at the simulation. It doesn't look like that the tool slams into anything it's not supposed to. It looks like it does all its cutting. All the toolpaths are either green or blue, or at worst yellow. Like, once that's all done, we can verify that the tool does exactly what it's supposed to, and the cut looks like something resembling our final product. We can post-process it, turn it into G-code. Or, yeah. So I'm going to go ahead and click that now. Now, we want to keep the configuration folder the same always. So this top one that's currently highlighted, make sure that doesn't change, because that's where Fusion 360 keeps all of its information on how to convert toolpaths into G-code. So we need Fusion to know where that is. That is really important. Under post configuration, though, just go ahead and click this drop down. You're going to look for, where is it? It's generic other mill, but here we go. Other mill. This is all in alphabetical order. Good lord. Under O, othermill.cps, generic other mill, and then in parentheses Otherplan. That would be the type of machine that you guys, either have used or would be using in lab. It's going to create a G code, as we can see over here. That's fine, as long as we know it's going to make a G code. That is fantastic. We're going to use the G code, and then give it a useful name. We're going to call it ring presentation. Ring presentation. And then once that's, well, actually, before we do that, we're going to change the output folder. I'm just going to change it to desktop, like I always do. But you guys, select a folder that will be useful for you. And I'm going to hit post, and it's going to ask me where I want to save it. And for some reason, it always defaults to not the output folder. So here I'm going to click on desktop again, so that we know we're saving it to the desktop. And ring presentation.g code, we know it's going to be a G code file, and I gave it the name ring presentation, so at least it was something somewhat useful. So that's fine. Once we've gotten all that, we know we're good to go. You can hit save. It will think, and it will pop up with the brackets program with all of the G code in here. And now we can see all of the G code that goes into cutting this ring out of a stock that looks like this. Now I'm going to keep Fusion open, but you guys don't have to. You're more than welcome to close down Fusion at this point, because there's another program we're going to transition into. And let me go ahead and grab the link for that as well, because this is, well, it's a program called Otherplan. And Otherplan is Othermill's software to run Othermill machines on your computer. So here we go, into the chat box, sent. I mean, even if you don't, download it now, at least follow along so that we can, watch the presentation so that you can get some idea of what's going on. Select your operating system. Unfortunately, there's no Linux available, but it shouldn't be an issue because I don't think anybody here runs Linux. The other unfortunate thing is that the OS X version is more well fleshed out than the Windows version is. I can say that from experience. But regardless, whatever, they both work. Just go ahead and download your operating system's proper version, and then it will spend a few minutes downloading an installer. And that installer will install the program. So we'll give everybody a few minutes to download the program and install it. And just, if you do that, raise your hand once you're done, so that we know, or rather that I know. Nobody else can see it, but I guess should know. All right, we got one hand up, two hands up. Three hands up. Wait for a few more and then we'll move on. Hey, four hands. All right. Wait for like one more hand and then we'll move on. Excuse me. All right, so let's go ahead and get the Otherplan program open. It's just on my desktop, so super easy. So this is what it looks like when you get it started up. It's a really straightforward, but at the same time, it's a very simplistic program. If you hold down right-click, you can rotate it. You can use the mouse wheel in order to zoom in and out. If you hold down the mouse wheel, or if you hold down right-click and use the mouse wheel, you can rotate it along the x-axis, around the x-axis, for some reason, or the y-axis, depending upon your orientation, I guess. Anyway, over it. And if you zoom out far enough, you actually get kind of like a ghost of the machine, which, you know, is always kind of helpful. Anyway, we'll need to set up our material. So we'll keep it on generic for now. But there is a little drop-down next to size, which we can click on, which will change the size of the material as one might expect. And we're actually going to make this, under width, it's going to be 3 inches. And it's not 3 millimeters, it's 3 inches. Okay, let's go ahead and see. Yeah, here we go. If you click Show Units in Inches under the top, under View, you can change the units over to inches, and then when we type in 3, it will automatically default to 3 inches rather than having to do some sort of mental gymnastics and figure out how much, 75 millimeters is in inches and all that kind of stuff, or 3 inches is millimeters. For depth, it's going to be 2.5 inches, at least in this particular example. And then for thickness, or height, it's going to be 0.38 inches. So you should have now a pretty well, relatively thin, but also sort of flat and wide material. And this is going to be the aluminum that we're working with. So now that we've got the stock material worked out, let's go ahead and take a look at that. And also you'll notice that machine disconnected is listed down here, or flashing down here. And it probably will be on your computer too, because you don't have another mill connected to it. But keep an eye out for that. If you're working on a computer that should have another mill hooked up to it, make sure that it's not incorrectly registering as disconnected. So that's obviously where we can modify the size of the stock. Placement tells us about the placement of the stock. We're going to keep the placement at origin, so at 0x, 0y, and 0z. So it stays right here in the corner because we want it there. That's where we're going to be working from. Maybe in the future you might want to have this stock be a little bit raised up off the ground or off center somehow, or close to center. So we would change the placement. But for now, we're going to keep it at origin because that's what we've been expecting, that's what we want, and that's where it's just going to be, the most helpful for us. At this point, you would probably also make sure you have the 1/8 inch end mill, flat end mill, on the CNC machine because that would be the tool we're using. So you always want to make sure that you've got the tool that you're using hooked up to the machine. It's a pretty important point. I mean, it seems it's a pretty obvious one, but I can't tell you how many times I've forgotten something like that when I'm working with a 3D printer or, just another type of machine, and I forget that I don't have the tip on the 3D printer, or I don't have the correct cutter on the mill or whatever, and so you get started and hopefully you don't end up dealing any damage to anything. But you got to turn everything off and start over again with the tool on there. It's just a function of, not enough sleep and too much work. It'll happen. It'll happen. Anyway, now that we got the size and the placement down, the material, we're just going to keep it generic. Don't even worry about it. It's just meant to represent some sort of material. So under plans, we're going to open files, go to the desktop, which is where I had it saved, and we're going to find ring presentation.gcode, or whatever you ended up naming it. Hit open, and you'll see that there are some toolpaths which are sort of ghosting into the material. It's really hard to see because they are a very similar color to the generic material that we have. But if you zoom in way close, you can see all these lines crisscrossing, which are meant to represent the milling path. Perfect. Now, the placement is at the origin. That's fine. We're going to keep it as it is. And then under milling tools, we're going to click that, and we're going to have a nice drop-down menu: engraving tool, brush wheel, grinding tool, 1/4 inch, 1/8 of an inch, 1/16 of an inch, 1/16 of an inch, 32nd of an inch, 1/100th of an inch, and then you've got ball mills and a probe. So we're going to use the 1/8 inch flat end mill because that was the tool that we were accounting for in Fusion 360. That is the representation. This is in a 1/8 inch flat end mill. So that's what the toolpaths were calculated for. That's what we're going to use here. Then you'll see that once you've selected that tool, it actually those toolpaths become a lot easier to see. They start glowing, and you can see material being cut away, or you can see the material that is meant to be cut away is sort of translucent at this point, and you've got a sort of, maybe difficult to see on my screen, but you've got a ring sort of floating underneath all of that shimmery, glowy, kind of see-through toolpath. We can hide the milling preview by clicking on that, but I don't understand why you'd want to do that. You'd like to have, well, sometimes you might want to hide the milling preview just to make sure everything's lined up. But once you've got that down, It's always good to just keep the milling preview, or at least most of the time, so that you can, just make sure. Oh, good Lord. You can just make sure that the cut looks like it's supposed to. There's a huge difference in one zoom level, like a ginormous difference. Okay, so this is the ring. Yeah, it's going to look a lot rougher, way zoomed in, but it is going to be a bit of a rough cut when it's done, so there are going to be other steps necessary. Anyway, we'll know that we've got everything set up because this start milling button will not be grayed out. It's grayed out right now because there's no other mill connected. But if there was, we've done all the things necessary in order to start milling, so this button would light up. And as you can see, you've got a little ellipsis, and then you've got this 56 and 3. That's an estimate of how long it's going to take. So this cut right here, this mill, would take 56 minutes and 3 seconds in order to complete. And then at the end of that roughly hour, we would have a ring. Now you could click start, and you'd probably want to just sort of watch it, at least at the beginning. Make sure it's not going to pull up the material or the stock or anything like that with all of its cuts. You can always just hit the escape button in order to cancel it really super fast and make sure that, like, no damage is done to anything. But otherwise, if you feel pretty confident in it, you can hit start milling, walk off, go do something else, come back in an hour, and you should have a mostly finished ring. I say mostly finished, it will be a ring, and it will be separated from the rest of the stock. As you can see. However, that would be largely what the end result would look like. However, it's not going to be necessarily a smooth ring. It certainly wouldn't be comfortable to wear. There are little bits of jagged metal on it and everything like that. The swarf, so to speak. And then it's going to be kind of rough looking. So at that point, you would go through the secondary process of sort of cleaning it up by hand, getting rid of the jagged edges, and polishing it, and just generally making it a nicer looking ring. But with that, you would have a ring made to order. It would be completely custom, perfect fit for somebody's hand, and it would also be something that you made. So that's kind of cool. But that actually just about does it for that presentation, I'll be honest with you. I knew it was going to be a short one. I didn't necessarily anticipate it was only going to take one lesson. So we might continue along the same vein with another project for Wednesday, and then see what we can do about next week. Or it might be we'll get started on something new on Wednesday. I don't know. That leaves, that's going to be, well, a surprise. We'll make it a surprise. At any rate, that does it for today. So I'm going to do the poll questions, and then if you guys have any questions about anything, well, I'll be here, as always, and be more than happy to answer those questions. So let's go ahead and do that real quick.